to really quantify the effects of food in space over the past 50 years, we can focus in on these four environmental factors and stressors: dehydration and freeze-dried food, radiation, microplastics in vacuum packaging, and this rating of how fresh, organic, and whole the food is. And so we can ask ourselves, which one of these has a greater effect on the degradation of vitamins and amino acids? Share your thoughts in the comments below. We've taken a deep dive here. So some astronauts say food tastes bland in orbit. And since the early 1960s, some also believe taste buds aren't as effective in space. With dehydration, food on the ISS has been refrigerated or dehydrated once every 90 days. And that food is mostly dehydrated. This primarily to prevent spoiling loss and the reduction in radiation damaging and upmass. And so, and then also there's the effects of radiation on food, which it's been well studied that liquid water exposed to high radiation produces reactive radical particle species such as OH-, which causes diseases, and that produces small changes in carbohydrates, lipids, amino acids. It's a study back in 1977, and we know that food is mostly water. And so here we can see the reaction pathways of the degradation of the bonds of water. And it's also been well studied the effects of microplastics on cause all sorts of inflammation, disease, insulin resistance, and BPA, BPF, BE. They disrupt hormones, lead to infertility, type 2 diabetes, heart disease, disrupt gut microbiota, and with radiation here in low Earth orbit, we know that if observed, half the dose on the ISS is expected to come from the trapped protons in the inner and outer radiation belt, and the other half from these galactic cosmic rays. That the beta particles are more penetrating than the alpha particles, being merely electrons that drive this molecular process of the scattering of ejected photoelectrons via X-ray emissions and Compton scattering. And it's been typically here on the surface, humans have used ionizing radiation doses to kill microorganisms on food, focusing in on the 0.1 to 0.5 dosage millirads on these fruits and vegetables. And so some believe this supports food storage, and the highest radiation doses, such as UVC, can kill most food spoilage organisms, parasites, and pathogens. And so the question becomes that, does dehydrating food remove nutrients? And if so, how much? Okay, so taking a deep dive here, dehydration of frozen food can drastically reduce the quality of food and cause nutrition loss. There's been vitamin A and vitamin C are destroyed by heat and air. That also the blanching of vegetables before drying can reduce vitamin C and B. I was surprised to learn here that the canning of food alone drives a 60 to 80% nutrient loss, and even frozen food drives a 40 to 60% loss of nutrients. Although the U.S. Department of Agriculture 2007 study found that there's a 3 to 5% nutrient loss from dehydration, where there's this slowed heat process that leads to less nutrient loss. And with 3 tables here on nutrient loss comparison charts of carrots, potatoes, and peas, that being from canned, frozen, and dehydrated, respectively. So here's a question for you. How much could dehydrated food reduce or delay the quality of food? And so to answer this question, we can jump into the amino acids and ask ourselves, which dehydrated bonds could be more susceptible to be bent or damaged? So let's envision the food in orbit traveling at 7 to 8 kilometers per second around Earth with these highly energetic particles with both an electric field and magnetic field that's bombarding food. And we can ask ourselves on a molecular level, well, why are the B1 and C vitamins some of the more unstable vitamins for storage and microgravity exposure? And we can further conduct the vibrations analysis of the carbon and hydrogen stretching and bending and ask, which weaker bonds, OH, CH, or CH3, degrade higher over time with given radiation flux. And so as everything in the universe, vibrates at a given frequency, we can ask ourselves, how much would these radiation fluxes increase or decrease the CH asymmetric stretching and wagging? Like your bananas wagging, bro. Most of the food is water. You can look at all this fruit and vegetables, 70 to 99% water. Here's here's another question. With a tomato made of 94% water, how do you fix a broken tomato? Tomato paste. So to wrap up here, some questions on food and space. How much could dehydration, radiation, and microplastics degrade the food, vitamins, and aminos? And if food on the ISS is not protected from radiation, what is the maximum days for food to be in space? And what are the microplastic levels in human blood and urine on the ISS? And given the loss of taste and smell in orbit, how would hydrocarbon degradation, off gas, with which volatiles in the back of the nose? And what would be the health effects from consuming these degraded food structures and free radicals, and their effects on the observed spaceflight symptoms? Okay, so maybe more questions than answers as usual, but we hope this guides our diets here on the surface and beyond.